Yes, you're welcome to today's class. This is part 8 of this project. So in today's class, we'll be designing beams. Last class, we designed slabs. All the slabs, we designed slabs in the last class. So today we are going to focus on beams. Okay, so if at this point you are yet to subscribe to my channel, I'll beg you to just hit the subscribe button, subscribe to my channel, and like my content, like the video, and share with your friends and your colleagues in the office and your fellow students as well if you are a student. We started this project from scratch, so we started the modeling and everything, and the architectural drawing of this particular project is also in the comment section, in the description. So it is there for you to just download. It's free of charge. Just download and practice alongside. This is the part 8 of this project. So once you download it, start from part 1 and follow the process from beginning to the end. We're going to finish this design, this channel. And once we are done with the beam designs, we will do column designs. Then we enter into foundation. Okay, so in this particular structure, you might be looking at designing a pile foundation for it. Of course, you know a lot of things are involved in pile foundation. So just stay glued in this channel, subscribe, and wait for it. Just sit back. I have a lot in this stuff for you.
Okay, I also have an ultimate Staad.Pro tutorial which has pre-recorded videos for 12 days. To just take you 12 days to learn Staad.Pro. I packaged it and arranged it for just 12 days. Every day, each day has a particular video to it. So it's a pre-recorded video. So if you want to get that particular tutorial package, the link is in the description. Just click the description, follow the link, and get and procure it. It's not expensive. Well, so as we are going through the training, you can also be contacting me on WhatsApp. My WhatsApp contact is also in the description, so that we have a seamless learning. So I will be with you. I will guide you. I have so many bonus packages included in that video. Like we designed a real life duplex. You know, everything about the duplex was designed. We also did a steel structure. The tutorial video covers, the training covers both steel and concrete. Designing concrete with RCDC software, which is also part of Staad.Pro, but it's a different software, but embedded inside Staad.Pro. We also did foundation design. So it's not something you're going to miss. You don't want to miss it. If you want to be very strong and sound and build up your confidence in the usage of Staad.Pro, that course is for you. Just get it. I'm going to be with you. We're going to be talking, even if you need the one-on-one discussion on a particular challenge you're having during the training. I'm always available. You can do a one-on-one. You can do it one-on-one, you know, through any means that we can find easy for us to use, be it a Google video or Teams meeting, or even if it is WhatsApp, anything. So just get it and we talk. Thank you very much.
Let's just quickly dive into what we have today. If you look at the property of this structure, the properties, let's see, we don't have a particular, I think we have different sections of beams here. Okay, we have this one, that's from first floor, second, third, fourth. You know, they have 600 mm deep and 0.225. Okay, so we're going to design a level to represent all of them. Maybe this one, this first floor, we design this first floor beam, okay, to represent the other floors. Then after that, we are going to design the second one, which is this. Yes, we are going to pick a floor here and design it. Okay. Then the third one is this cantilever beam. So you are going to also, of course, it's going to be when we design when we pick a floor and design, every of these floors has the cantilever. So we are going to be designing the cantilever beam there. You know, once we pick a floor, particular floor, we design them together. But we are also going to pay special attention to this last level where we have our water tank. So we need to design it as well to see if the roof beam there can be able to withstand the load the point load which we applied. So if the beam is failing, we will quickly increase the depth. So let's start. Okay, the first thing we do is to analyze. Of course, we have to run analysis. We have already we closed the software, so, and relaunched it. So before we can continue with design, you have to rerun the analysis. So that one is not in news again, is our norm. Okay, so we say okay, and we go to the advanced concrete design, which is also known as RCDC. Click on that and wait for it to come up. It's going to take some time. Okay, it's coming. Okay, so it's up already. So from here, the same thing we did in the last class, we are going to fill in this gap. The project name, just type the project name. The client name, type the client name. The engineer's name, you can put your name there, or the name of your company. Then the design code, you can use Indian standard, you can use the BS code, you can use ACI, you can use European norm, you can use NSCP, you can use American, you can use AS. Yeah. Okay, so in this case we are using a European norm, that's a European code. Okay, Euro code number 2. Euro code 2 is for concrete design. Okay, from here we choose the beam. We have to choose the beam. Then we select the level at which we have our beam. So we are using the first floor beams. As example, it's going to represent the four the remaining floors. So we click on OK. Then we click OK again. Then wait for it to come up again. It's going to take some time. Just have to be patient. Okay, it's up already. So we need to now look at what we have there as the beam layout. Does it actually represent what we have in the drawing, in our model? So this is what it is. We have beam 1, beam 2. That is how it's modeled. Beam 3, beam 4, beam 5, beam 6, beam 7, beam 8, beam 9. So just like that. So when you finish designing of this beam, you can decide to renumber the beams, because the way we used to number our beam is not by numbering them from span to span. We can just call this whole length beam 1. This other length, we can call it beam 2. You understand, like that. So this one also can just be beam 3. Just give a number, just a straight beam, you give it a number. You understand. Then this one can be will be a particular number on its own. Then this can be one number. So but that one is when you finish designing, you can the process of fine-tuning the design, yes. You can, like, I'm also trying to get a software which can help you fine-tune your drawing. Software that can do 70% of the work for you, and the remaining one is just to do 30%. You get, and that software also has templates of various designs. The strength of every engineer is the template you have. There is no work you will do today that has not been done in the past. So you just need an idea of what is expected of you to produce at the end of the day. So when you are done with your designs and you have given the draftman to draw for you, you should be able to have an idea of what you're expecting from the draftman as an engineer. Because when the draftman is done with your drawings, you should be able to check. So if you are the one doing the drawing yourself, you should also be able to know what is expected of you to produce. You understand? So template is the strength of every engineer. You need to have templates, a lot of them. So I'm working on that already. very soon it's going to be posted here on my channel. So stay glued. I have so many things for you. So that template is going to have a lot of things, variety of designs, a whole lot of designs that if you have that kind of design in the future, you just need to do your analysis and design and bring the drawing there in that template, and you just match properties and align your designs to look like that with your own dimensions and properties. You get the proper. Yes, that's just it. Okay, so let's continue. Once you get it open, like these are the beams, so you can see once you click on any one, it's supposed to is highlighting. So this is G2, that's the grid line number 2, I think, starting from here. So you come to 3, that's that. You click on the 4th one, the 5th one, the 6th one, the 7th one, okay, the 8th one, that's that. So as you highlight, you see the beams where they are. That's how the software is going to design them. Okay, that's that. So we are going to now okay, look at these are the beam numbers as it is there, beam 1 to beam 35. So these are the dimensions: LBD. L is the length, B is the breadth, and D is the depth of the beam. So like that. So all these beams have the same breadth and depth. Okay, so that's that. So we are not doing anything here. We just come to these settings and hit on general and reinforcement. So we just click on this one. So here we will not ignore torsion. We won't ignore torsion. Okay, so just look forward to change here. Perform crack check. Yes, our crack limit is 0.3 according to the code I'm using. Okay, so here we will consider bending design. That's good. Here concrete braid is going to be 2530. Okay, so steel grade I'm going to use 410. That's good. Then maximum aggregate size, okay, is 25, is good. Clear cover to reinforcement for my beam, I think something 30 mm is better, is fine. Okay, so main steel rebar minimum, main steel for my beam minimum should be 12 mm. Then maximum can be 20. Yeah, okay. Then shear steel rebar, it can be 10 and 16, it's fine. Then SFR, that's the reinforcement that will be in between the top and bottom reinforcement. So you still can use a 12 and still 20 can still come in for that one. Okay, so you have a stirrup spacing, minimum spacing of stirrup for my beam minimum, let me use 150, and maximum spacing should be like 250. 200 is still fine. So okay, I'm done with this one. I'm just gonna hit okay. Yes, so I'll click on settings again, go to rebar curtailment, so you can check if you need to modify anything here. Top steel curtailment location, I'm not modifying anything here, I like the way it is. So detailing and drawing settings, if you need to do any settings, any settings, sort of cantilever type, back, all those things, development length, if you want to fix the length, so there are certain rebar mark manager, so you can change the text for the rebar mark. I normally like using H, and some persons use R according to code anyway. You can use, I could just consult your code. For Eurocode, Eurocode supports H, yeah. So that's that. You go to settings again, preferred bar spacing. Okay, I'm not doing any much thing here. Spacing. Okay, so basic load cases. So this is very important. Without this, we will not be able to design these beams. So load load number one is self weight load. So from here you need to define the load type. So is it a dead load or a life load or reducible life, or it's quake, earthquake in X direction, Y direction, wind? So this from here you specify which load is which, so that the RCDC will be able to do the be able to identify each load as they are in the model and the analysis phase. So I'm going to select this self weight. Of course, it's dead load. So the second one is still dead load. The third one is still dead load. The fourth one is dead load. The fifth one is life load. The sixth one is life load. The seventh one is wind load in X direction. Then the last one is wind load in Z direction. So after that, you select all the load and click on this double arrow here to add all of them. So once that is done, you click on OK. This is OK. Then these are two options. You have add from template. If you have a template where you have your load combinations for a concrete building, you can just go to that template and import your load combinations. But there's another one here which I prefer, which I normally use. It says add from analysis. Of course, in our analysis phase, we are able to do our load combination. So I will just add the load combination from the analysis. So you just click on this button, and quickly the software will import all the load combinations in our Staad.Pro, which is here. This is the load combination, and you see design, that's for strength. It has already selected the ultimate combinations for strength design. So these are the serviceability is not highlighted, so it's not going to use this one for design. So after that, because we have asked the software to also do crack check for us, so we need to also select the load combination for the crack check. So you click on the crack width tab, and also click on add from analysis. It will also import those analyses, but it will now ask us to use our hands to select the load combinations for the crack width check. So I'm going to check on the serviceability loads for the crack width and click OK. So now we are done. The next thing is to click on design and wait for our design to come. It's gonna wait. It's gonna take some time, so we just need to be patient and wait for it. Okay, our result is ready. So we have a beam here that has failed. So you look at what the report we're having here, say failed beam groups G5 and G11. So we have G5 here. So it's not only one self. We have G5 here, and we have G11 here. So we have two beams that failed. So we are going to look into it. We are going to look into the beam. So G5 and G11. So we look at design input. So where is our G5? This is G5. So this beam has failed. This beam is failing. And G11, this one has also failed. So we are going to do something here. So these are going to be our special beams. So of course, when a beam fails, we need to the first thing we need to do is to increase the depth of that beam. So we are going to increase the depth of this beam from 600 to 650 or 750. Yeah, we are going to increase it to 750. So how do we do that? We can go back to this our design, and we right click
and select that design. So it will now bring us here. So from here we can now change anything we want to change. Concrete grade, we are not going to touch the concrete grade. Concrete grade is okay. So steel grade is 410. I'm going to use it that way. It's okay too. So where I need to change is this depth. So I'll simply put 750 here. Okay, 750 for all of them. So that my beam is going to be 750 you get for them. So when I'm done changing it, I'm gonna hit this redesign button and see whether it's going to pass. Okay, so we wait for it to come. So I'll still have some of the beam failing. Okay, so because it failed again, so we have two options here. Is either we go back to the model and look for a way to introduce columns, under those beams, or we increase the depth again. These are the two options. So you can go back to your model and look for places to put more columns under those beams, and of course it's not going to stop at first level. It has to continue because these beams are the same thing, and they are carrying the same load. The load from slab is being transferred, of course, so to those beams, and they transfer them to the column. So you get two options. Either you keep increasing the depth of this beam, or you go and introduce more columns under those beams. So but let me just increase the depth so that we can end this course. I will put depth of 1000 here. So it's actually a special beam in this particular building, so it's expected. The building is a 7-story building. So okay, so this is it. So, and the concrete strength is another factor that we can also increase. So they will pay special attention in the casting of this. So you have to make it known in the drawing that these particular beams have a different concrete grade. But let me just run the analysis and see if it's going to pass under this concrete strength. So if it does not, we increase it. Or the way it is, I don't think it's gonna pass. If it does not pass, we just increase it and so you see it's not passing. So let's check let's increase it. Okay, and design again. I believe this one will go. Yeah, that's that. The design is done already and it has passed. So we have the reinforcement details here. So we just quickly accept. Once you click on accept to update the design immediately, and you see that G11 has passed. So we go to G5 and do the same thing. So let's see again where the G5 is. G5 is okay, this one. So let's try and see what we can do, for the G5. Okay, so here you right click again and click on design. You see, so we are going to increase this depth again. Let's try 750 before we go to a bigger depth. 750. Okay, so let's design and see what's going to happen. So if that happens again, we'll just take it to what the other one accepted, to 1 meter depth. See, that's the same thing. So we just do 1 meter depth, 1 meter depth, or 2. So that's these two beams will be our special beam in this structure. So we are going to pay special attention for them, or we go and introduce more columns under those structures. So from here we are going to increase the concrete grade and we design. So the mix ratio for these beams and the other structural members are not going to be the same thing. Yep. So here we go. It has passed. So we accept. Once you accept, the design will update. So everything has passed. Everything has passed. So let's look at our output. So just like we did in the previous class, the same thing. You can get your output. This thing. Um, the reporting. This is the text schedule. For the beams. Okay, we can do elevation and section for all the beams. So from here you give instruction of what you need to see in the drawing. So we need the elevation, we need cross section, we need the cross beams. If any beam is crossing, okay, you can mark the anchorage, show section mark. Okay, these ones are good. So if you need to go and do your detailing sections, you can come here and do that. So we say okay. Okay, this is our beam detailing. So you can just take this to AutoCAD and quickly the design will be done. Design is done already. These are the beams. These are the section, the 600 by 225. This is the beam and the section of the beam. Okay, this is what it is. All the beams have sections. Okay, that's fine. Okay, so you can as well, the same way we did in the last class, you can as well generate design summary. Okay, if you wish to use design summary, attach the design summary to your report, just open it from there for the design summary. You can as well open the design calculation. That's the comprehensive design report. For a particular, you can choose a particular beam or you choose for all the beams. Just click OK. And while we wait for them to come, so the next beam we are going to design is the one for the 5th floor, 6th, and the 7th floor. Then before we check the one that has that is carrying our overhead water tank, and after that we are done for beam design. Okay, so this is the report. So this design summary. Design summary is just the summary of all the design. So it's just it just summarizes all the beams and all the checks. But this detailed report is also very well detailed. So this is the one I normally use for my designs. After preparation of my design report, this is normally what I attach. So you can attach it by printing to PDF. Once you click on print, you print to PDF instead of sending to printer. Just send to PDF, and this is a printer name. So you can select PDF redirect, and once you print it PDFs the document for you. It becomes a PDF document. So now we'll quickly go back to our model and start the process of the second stage of the design, which is the other side of the floor. So we are going to close this. So all this drawing, of course, you can export them to AutoCAD, and by the time I give you the software, which I'm going to be introducing very soon, it will help you to fine tune all these drawings, and your work will be very much ready to be sent to your client, and you get your dough. Okay, so let's move to the second one. You can as well save if you want to save. Just click on save and it will be saved there. You can as well find your saved file from there. Okay, so we are back to Staad.Pro model. So we are done with this first other one. So the second one we are going to do is the one that has depth of 0.45. So that's this one. So we are going to be designing this, but from all indication, I don't think this beam is going to even pass at all, because the other one struggled to pass. So this one's I'm envisaging that it's going to take the same shape that this other one took, which is the same depth. So yeah. So but let's just try it. So we have this to be the 1, 2, 3, 4, 5, or 6. Let's design for any of these, 5 or 6. So we go to RCDC. The same thing we did initially, we're going to do it again. Okay. Okay, so we write the name of client, the engineer name, select your code, then the beam level is 1, 2, 3, 4, 5. Let's design the 5th level. Okay, so we click on okay. Okay, so this is our beams. So you quickly do the settings, you know. So here we use 2530, 410. Cover to reinforcement is we use 30. Okay, average maximum aggregate. Okay, so the main steel rebar use 12 minimum, 20 maximum. Shear steel we use 10. Okay, this one will still be the same thing, and we can put 20 here. Then the minimum spacing is 150. Okay, maximum spacing can be 250. Okay, we perform crack check 0.3 maximum. Okay, do bending and axial force design. Yes. Okay, so I'll click on okay. So we go back to settings again. I'm not actually doing anything here, so I'll click on basic load cases. So this is dead load, dead load, dead load, dead load, life load, life load, wind load in X. Then you have wind load in Z direction. Then you push them there and click OK. Click from analysis. Click OK. We select the crack width from analysis again. Then we select this ones. Okay, so click on OK and hit on design. Let's see how our beam is going to behave. Okay, so in this case, all the beams passed. So here is passed. So this is a typical example of when you have a tall building, you'll be reducing the section sizes as you go up. So you see the first set of our beams, they have a bigger, they have a bigger section than the second set that we just designed now. This is the second set that we are designing. Is just the same thing will happen with our columns. So now this is the design of uh, our second set of beams. So nothing failed here, nothing failed exactly. So we do the same thing to export the designs. So we can just look at the elevations and sections and see how the beam detailing is looking like. Of course, you can also export the BBS and the reporting, everything. RCDC gives you everything you need to know, everything you need to see. It's a very good software. Mark encourages. Okay, let's see the bar bending. No, not the bar bending, the detailed drawing. The detailed drawing. Okay, so this is beam number 1. This is the size. Beam number 2, that's the size. This one is the cantilever beam, because you see this other adjoining beam coming from the other side. This one is the column. Okay, this is the adjoining beam coming, which is the same size. So this one is not having any issue. Okay, so this is the section. Very simple. It has given you everything. Everything is given. Everything is also done. It's done for you. So this one is the beam 3, beam 4, because so is the section of that. Okay, that's 450 beam. Okay, so this is beam, okay, beam 5, beam 6, just like that. So we don't need to worry for the drawing. You don't need to start drawing from scratch at all. You don't need that. Time has passed when we use work to kill ourselves. The technology has made things very easy for us. So just get this software and try and if you don't know how to use it for you don't know how to use it, just check my the link of my ultimate Staad.Pro tutorial in this description and download it. You can be in touch with me. We talk. My WhatsApp number is there. You communicate through WhatsApp from any country of your choice. You can talk. WhatsApp is worldwide. You can just communicate and talk. So I'll guide you all through the training. Just the 12 days tutorial. It has pre-recorded videos, in there covering steel and concrete. So you need to. It's not something you're gonna miss. Just pick it up. It is affordable as well. Okay, so now let's look at how we are going to consider the other level of beam, which carries our water tank. I believe the size we gave it actually work. So let's just close this so we can save. Yeah. Okay. So the last one is on the last floor of the building. So we just click on advanced concrete again. Yeah. So you must come back to the model before you pick up another section you want to design. So it's not, you can't just enter into RCDC and from there you pick whatever you want to design. So you have to come back, so that you keep selecting. So that's how it works for now. Let's see if they will modify it later and add such feature where you can just, once you enter into RCDC work interface, from there you can pick whatever you want to design. But for now, this is what we'll be doing. So it's still beams. So I will select the last level and see what is there. Okay, so click OK. Okay, unfortunately that this is not capturing the last level of that beam. Is not capturing it.
Okay, so it's not a big deal. We just use the properties for this one and use it there. Okay, so the it's not a big deal. Okay, so you're supposed to capture it, but it's not capturing it. Okay, with this we are done with the beam designs. We are done with the beam design. So we'll end here for today. In our next class, we will be doing the column designs. Our column design is going to be interesting because I know a lot of columns are going to be failing. Yeah, so we'll be doing a lot of front and back, changing of sizes and sections. So stay tuned. Stay tuned. That's going to happen very soon. So if you are yet to subscribe, please hit the subscribe button. If you have learned something, just like the video, please just like the video. Your like helps to push the content to other people. YouTube recommends a video that is more liked, because they feel that people they like that particular video, and they will feel like to share the video and suggest it with other YouTubers. So just like my content, it helps me a lot. And subscribe and share with your friends, well wishers, and your fellow colleagues. Okay, thank you very much, and thanks for watching.